Good afternoon, everybody. Good morning, good evening, whatever time you're watching this. I'm Dennis.
I'm Katie.
I'm Zach.
And we are here because we love chemistry. And we just love limiting reactive problems. So, what we're going to do is we're going to go through our reactions. I'm doing number 59. Katie?
I'm doing number 69.
I'm doing 63.
So enjoy, and please give us positive feedback. Thank you.
Hello everyone, my name is Katie, and I'm going to show you the equation that we'll be working with today. It is N2 plus O2 produces N2O3. First thing that we need to do is look and see if our equation is balanced. It's not balanced, so what we're going to do to balance it is put a 2 by the nitrogen gas and a 3 by the oxygen gas. Okay, so now that our equation is balanced, we can move forward. What we're going to do today is find out that if 70 milliliters of nitrogen gas reacts with 45 milliliters of oxygen gas, what is the volume in milliliters of dinitrogen trioxide produced? So first thing that we're going to do is we're going to find our limiting region. To do that, we're going to convert nitrogen gas and oxygen gas into moles. So we're going to take 70 milliliters, which is what we're given, of nitrogen gas, and we're going to convert that into moles. First thing we need to do though is convert it to liters. Milliliters to liters, liters to moles. To do that, we need to choose the right unit conversion factor that when our milliliters will cancel out and we'll be left with liters. To do that, I'm going to choose 1 liter of nitrogen gas over 1,000 milliliters of nitrogen gas. And that is going to give us 0.07 liters of nitrogen gas. Now we want to convert liters to moles. So again, we're going to choose the right unit conversion factor. I'm going to choose 1 mole of nitrogen gas over 22.4 liters of nitrogen gas. 22.4 liters, that's a known number, it's something you have to memorize. What it means is that molar volume is the molar volume for gases at standard temperature and pressures. So we're going to assume that these gases are at standard temperature and pressures. So that for that we're going to assume that it is 22.4 liters of nitrogen gas. So 1 mole over 22.4 liters. Our liters are going to cancel out and we're going to be left with moles. That is 0.003 moles of nitrogen gas. Now we're going to do the same thing for oxygen. We are given 45.0 milliliters of oxygen gas. We want to convert milliliters to moles. So first we have to convert it to liters. We want to choose the right unit conversion factor to where milliliters will cancel out. So I'm going to choose 1 liter of oxygen gas over 1,000 milliliters of oxygen gas. This is going to equal 0.045 liters of oxygen gas. See, my milliliters canceled out, so I'm left with 0.045 liters of oxygen gas. Next thing I want to do is convert this into moles. So I have to choose the right unit conversion factor to where liters will cancel out and I'll be left with moles. How I'm going to do this is I'm going to choose 1 mole of oxygen gas over 22.4 liters of oxygen gas. Again, this is a known number. It means molar volume for gases at standard temperature and pressures. So this is going to have my liters cancel out, and this will equal 0.002 moles of oxygen gas. Now we know our limiting region. Our limiting region is oxygen. So limiting region is 0.02 moles of oxygen gas, or 45 milliliters of oxygen gas. So now we're going to take our limiting region, and now we're going to find out how much dinitrogen trioxide can be produced. What limiting region means, by the way, is that our production basically stops when our limiting region runs out. So we're going to run out of oxygen before we run out of nitrogen. And we need oxygen and nitrogen to produce dinitrogen trioxide. So we're going to see just how much we can produce before we run out of oxygen gas. So to do that, we're going to take 0.002 moles of oxygen gas, and we're going to choose to, we're going to have 3 moles of nitrogen gas over 2 moles of oxygen gas. And what this is going to do is this is going to tell us how much dinitrogen trioxide can be produced from 70 milliliters of nitrogen gas and 45 milliliters of oxygen gas. So this produces 0.0013 moles of dinitrogen trioxide gas. But if we remember from the beginning, we want to find out how many milliliters by volume of dinitrogen gas is produced. So we need to convert moles to milliliters to get the answer. So now we are going to have 0.0013 moles of dinitrogen trioxide, and we're going to use a unit conversion factor that will produce liters, and then from liters we'll go to mole. We will convert to moles to find our answer. So we are going to choose 22.4 liters of dinitrogen trioxide gas over 1 mole of dinitrogen trioxide gas. This will give us a liter, so this equals 0.02912 liters of dinitrogen trioxide gas. We're almost there. All we have to do now is convert liters to milliliters. So we have 0.02912 liters of dinitrogen trioxide gas. We're going to choose a unit conversion factor that will have liters cancel out and give us the answer in milliliters. So I'm going to choose 1,000 milliliters of dinitrogen trioxide gas over 1 liter of dinitrogen trioxide gas. And I'm going to round this number, so our answer is 30.0 milliliters of N2O3 gas. So if we have 70 milliliters of nitrogen gas react with 40 milliliters of oxygen gas, provided that the gases are at standard temperature and pressure, it will produce 30 milliliters of dinitrogen trioxide. Thanks everybody, hope you had fun.